Hello and welcome to our chemistry project video. Today, as you can see, we're going to be talking about valency, more specifically how valency relates to the different groups of the periodic table. In case you don't know what valency is, don't worry, we've got that covered as well. So for now, just sit back, relax, and enjoy the video. Okay, so let's say that green dot on the screen is the nucleus of this oxygen atom. The nucleus of an atom is made up of neutrons and protons, and is basically the core of an atom. The electrons of an atom circle around this core in layers, which are also known as shells. Now these shells are going to be important when we're going to start talking about valency. So the green dot is the nucleus, and we have two layers of electrons or shells surrounding the nucleus. There are rules regarding these two shells, or more shells on other atoms, but basically in the first shell, or the closest shell to the nucleus, you can only have a maximum of 2 electrons. So if you have more than 2 electrons in that atom, then they're going to have to be pushed out into the second shell. So here we have oxygen has 8 electrons. Here, okay, so first shell only contains 2, and 8 minus 2 is 6, so 6 electrons are pushed out into the second shell. And there's another rule for the second shell onwards. Basically, you can only have 8 electrons from the second shell onwards. So if you have even more than 10 electrons, so first shell has 2, next shell can only contain 8, and if you have more than that, you're going to have to be pushing out more electrons into a third or maybe even a fourth shell, which both only contain 8 electrons. But how does this relate to valence electrons? Well, valency is basically the number of electrons in the outermost shell of the atom. So in this case, oxygen has 6 electrons in its outermost shell, or I guess the second shell. You can see 6 shells in its outermost shell. Oxygen has a valency of 6, and that's basically it. Valency is only the number of electrons in the outermost shell. And the valency of an atom varies from atom to atom, but there are overlaps, and the periodic table conveniently takes these overlapped elements and puts them in a column called a group. And whether the atoms have more electrons than the other, all the atoms in the group have the same number of valence electrons. And this could come in handy later on when you're studying chemical reactions or chemical equations and things like that. Okay, so here's another example of valency. Hydrogen only has 1 electron, and there's only 1 electron, there are no other shells, and so the first shell becomes the outermost shell, and it has a valency of 1 now. So now that you know what valency is, we're going to show you how it can be used in kind of examples during chemistry.
To explain valency, let's use sodium chloride as an example. Sodium chloride is also known as table salt, the one which we eat every day. Sodium chloride is composed of two elements from the periodic table, sodium, which is expressed in the symbol Na, and chlorine, which is expressed as the symbol Cl. Sodium, which has a symbol Na, has 11 electrons. Sodium has 3 shells of electrons, and the first one contains 2 electrons, the second one contains 8 electrons, and the third one contains only 1 electron. We circled the number 1 because number 1 is also explained as the valency electrons, which also means the electrons in the outer shell of an atom. Let's keep the valency of sodium on our mind as we go on to our next element, chlorine. The next element, chlorine, which is expressed in the symbol Cl, has 17 electrons. It has 2 electrons in the first shell, 8 on the second, and it has 7 on the third shell. The valency of sodium 1 and the valency of chlorine 7 add up to number 8. The number 8 shows that the sodium chloride, NaCl, is a stable element because it has a full outer shell. Sodium and chlorine itself is a pretty unstable element because it does not have a full outer shell, just like how sodium chloride has. In order for elements to obtain the valency of 8, they must react. We see many elements which do not have the full outer shell, such as chlorine and sodium in this example. But just like what they did, elements can react in order to obtain a full outer shell of 8. The valency of an electron is tend to be determined by the groups the element is in. For example, sodium, which is in group 1, has a valency of 1, whereas chlorine has 7 valence electrons because it's in group 7. Group 1 and group 7 tend to react with each other because the valency electrons of 1 and 7 add up to 8.
Thank you for watching our chemistry project video. We hope you learned something new, and if you want to learn more about valency and their groups, you can visit the link in the description for further information.